And we kick into our fourth section of the review chapter on rational expressions. And there's also going to be some stuff with radicals. Rational expressions are just kind of fancy name for fractions with variables. And we have, just with regular fractions, we have to remember one key fact, and that is you can't have 0 in the denominator. If it's a fraction like 3/7, we don't have to worry about that because the denominator is constant. But when you throw a variable into the denominator, you have to worry about what might make the denominator 0, or make a list of restrictions. I have an example right here. My denominator is x minus 1. What makes x minus 1 equal to 0? Well, 1 makes x minus 1 equal to 0. And now I know negative 1 makes the numerator 0, but you can have 0 in the numerator. You just can't have 0 in the denominator. So when it says list restrictions, we're not going to say x equals 1, we're going to say x cannot equal 1, and that's how we list the restrictions. Sometimes there's a single restriction, sometimes there might not be any restriction, sometimes there might be many restrictions depending on the denominator. Now, a very, very simple definition of a rational expression is a ratio of two polynomials. Again, the denominator can't be equal to 0, but we sometimes think of it as something like p of x over q of x, where q of x cannot equal 0 as long as p of x and q of x are polynomials. Now, polynomials can be constants, so when you have a fraction like 3/7, technically that's a rational expression. We typically call it a rational number, but it's a rational expression as well. So I have three examples that are talking about the restrictions of the variable. And again, we look to the denominator. In the first one, x plus 4 over x minus 3, my denominator is x minus 3. I said x minus 3 equal to 0. I solve this simple equation. I get x equals 3. My restriction here would be x cannot equal positive 3. I'm going to write it out that way. Now, if the directions ask for you to find those values that make the denominator 0, then you would say x equals 3. But when they're asking for the restrictions, we use the do not equal to symbol. My second one is a little bit more complicated. C squared minus 16 is my denominator. If I set this equal to 0, I would get c squared equals 16. I would get c is equal to plus or minus 4. I have two values there that make my denominator 0. So I'm going to list my restrictions as c cannot equal plus or minus 4. If you want to, you can write 4 and negative 4 separately. My third one, the denominator is a monomial. 7ab to the second power. You have a product of three factors there. 4 if you want to count the two factors of b. 7 is a constant, so that can't be 0. But the only way a product can equal 0 is if one or more of the factors can equal 0. So either a is equal to 0 or b squared is equal to 0, which would mean b is equal to 0. So my restrictions here, a cannot equal 0, b cannot equal 0. I have more than one variable, so I have to list both restrictions. Now we simplify rational expressions. If you remember back to your fraction days, when they discussed what a fraction was, they talked about simplifying fractions, like the example that I have up here of 18 over 24. 18, of course, is 2 times 3 times 3 if I write out the prime factorization. 24 is 2 times 2 times 2 times 3 if I write out its prime factorization, and we look for common factors that technically we don't cancel, that's why they're in quotes, cancel the common factors. We're looking for factors of 1, and of course when you multiply by 1, it's not going to change the value. So I have 2 over 2, and I have 3 over 3. I could cancel either one, but not both, just one of them. So that ends up with 1 times 3 times 1, or 3, and on the bottom 1 times 2 times 2 times 1, which is 4. Now, I know you don't necessarily simplify fractions that way. By now you're doing it in your head. But you wouldn't break them down to prime factorizations. You'd just say, what's the biggest number, the greatest common factor of 18 and 24? And so that would be 6. 6 goes in 3 times, 6 goes in 4 times, and you jump right to the answer. Well, just like we simplify rational expressions that are fractions, we simplify rational expressions that are not necessarily set up as fractions, and we definitely have to use our factoring from the last section. So when you have factors written out this way, you can cancel common factors. But these are not factors, these are terms. So you must break them down into factors. The GCF up here is x, so I can write the numerator as x times the quantity x minus 8. Down here, I would kind of do a reverse FOIL here with an x and an x. I'd need two numbers whose product is negative 8, whose sum is negative 7. I'm thinking negative 8 and positive 1. Well, now I can see that the x minus 8 factor in the denominator and the x minus 8 factor in the numerator will cancel out and simplify. And so I end up with x times 1, which is x, all over 1 times x plus 1, which is x plus 1. Careful, careful, careful here. I have a lot of students that want to cancel these x's because they see the x in the numerator and the denominator. The x in the denominator is not a factor, it is a term. So you can't cancel terms, you can only cancel factors. That's as far as that one does simplify. Now my second one doesn't even have a variable, but it has a radical expression there, the square root of 5, which kind of gives it a little bit of a twist. What we're going to do here again is we're going to look for common factors. So don't cancel the 3 and the 6, or the 9 and the 6, because the 3 and the 9 are in terms. What you want to do there is factor this, just like I factored this numerator, by taking a greatest common factor of 3 out. Of both, GCF of 3. Now the 3 is a factor, the 6 down here is a factor, 3 goes in once, 3 goes in twice. I end up with 1 plus 3 square roots of 5, all over 2. They may ask for you to write it like this, but most likely this way. But they're equivalent expressions. Alright, I saved the most interesting one for last there, 5 minus x and x minus 5. Now we know when you have the same thing over itself that it's equal to 1, but that's not the same thing. Remember, you cannot commute subtraction. 5 minus x and x minus 5 are not the same binomial, they're opposites. If I was to factor a negative 1 out of here, I would have x minus 5. So that I could cancel the x minus 5's top and bottom, I have negative 1 over 1, which is negative 1. When you see this little negative 1 trick a-coming here, when you see opposite binomial factors, you don't have to necessarily go through these steps. You can go ahead and cancel as the factor of negative 1, jump right to there, and then of course to the answer of negative 1.